This is MOM Z14 and it's the farthest galaxy ever discovered. It's about 13.5 billion light years away from us. That means the light from this galaxy spent 13.5 billion years traveling through space before it finally reached Earth. And here's something really interesting. This galaxy sent out the light about 13.5 billion years ago. Now, the universe itself is about 13.8 billion years old. So, this galaxy must have formed just around 300 million years after the Big Bang. But for us, the question is how do we even know how far a galaxy is? Okay, let me ask you a simple question. Imagine 13.5 billion years ago, this galaxy released blue colored light. And now you are seeing that galaxy from your telescope. What do you think it would look like? You must be feeling that it should look like a blue colored galaxy. But surprisingly, it would actually look red. This happens because of something called redshift. But what exactly is redshift and why does it happen in the first place? So this is light and light is a wave. Now every wave has a wavelength and if you change this wavelength you will get different types of light. For example, light of wavelength 450 nanometer is a blue colored light, but light of wavelength 750 nanometer is a red colored light. So in simple terms, 13.5 billion years ago, this galaxy released a light of wavelength 450 nanometer and now you are receiving it as a light of wavelength 750 nanometer. But what can cause this increase in wavelength? This actually happens because the universe is expanding. That might sound a bit strange. Let me explain it more clearly. Imagine that 13.5 billion years ago, our universe looked like this balloon. At that time, the light coming from this galaxy had a wavelength of 450 nanometer. As the universe expanded, the light wave stretched along with it. This increased its wavelength, so by the time it reached us, it became a red colored light of 750 nanometer wavelength. This effect is called redshift, but does the redshift mean that every red colored galaxy in this image is billions of years away from us? Actually, no. We know the fact that early galaxies were made of hydrogen, and hydrogen emits light waves of specific wavelengths. For example, one of them is called Lyman alpha, having wavelength of 121.6 nanometer, and another is H alpha, having wavelength of 656.3 nanometer. So when this galaxy emitted these waves, and now if you detect light at wavelengths that are 15 times longer than Lyman alpha and H alpha values, we can tell that this light is coming from a very far galaxy. This also tells us that the universe has expanded by a factor of 15 since the light left that galaxy, and the amount of redshift would be 14. But if the wavelengths of the detected light increase by different amounts, then we can't be sure that the light is coming from a very far galaxy. Now, we already have an idea of how the universe has expanded over time. Basically, if you calculate an expansion factor of 15, it means you are looking at a galaxy that released its light when the universe was only about 280 million years old. In fact, an expansion factor of 15 is so large that the stretching of light shifts the original light all the way into infrared light. We can't see infrared light with our eyes, and most ordinary telescopes can detect it either. That's one of the main reasons scientists built the James Webb Space Telescope. It is specifically designed to capture infrared light. Using this telescope, astronomers discovered MOM Z14 on May 16, 2025. So far, it remains the oldest and most distant galaxy ever observed.